Hello, my name is Evgeny. I'm presenting a study about the approaches for utilizing modules in the Heta modeling language. Today, mathematical models are often applied for research in biomedicine and pharmacology. Models may be very complex and include thousands of components. The code modularity is a powerful approach for the software engineer, but it's hardly ever used for developing of large mathematical models. This study demonstrates the implementation of the approach in the Heta modeling language. Heta is a human-readable and writable modeling language based on the process description format. It's used mainly for quantitative systems pharmacology and systems biology models, but it also can be used for broader area describing dynamic processes. There are several software tools that allows working with Heta formatted modeling platforms. For example, Heta compiler and Heta simulator. I'm going to show you several mechanisms in the Heta format that allow to work with mathematical models as building blocks. First of all, the Heta platform can be split into several files. Furthermore, each of the files can be written in different formats as a human-readable code, table, YAML, or even SBML file. To unite all the files in one modeling platform, a user can apply include action. Here we can see a hypothetical example describing metabolism of a cell type in the blood volume. For better readability, the whole model code was split into two parts. The first one describes intracellular process, another one describes cell proliferation. Both files are combined in the index Heta file, which loads them sequentially with include statement. A user can describe how to split and combine modules depending on model size and complexity. The Heta syntax makes it easy to reuse previously created code. Three basic actions, insert, update, and delete, allow to change model components in any part of the code. The next example updates the transport process and adds a species into the model. Note that the initial modules remain the same. So the Heta syntax helps reuse of code blocks without updating source files. The another layer of modularity is a system of internal namespaces. The namespace in Heta is a separated part of a modeling platform which can be interpreted as a submodel. The created models can be independent or share common parts. The example here demonstrates the initialization of a new namespace entitled as intracell. After that, we include the Heta module and set cell count component as a constant to exclude process of proliferation. At the end, we have got two models in one platform, and these models have common parts. The next example demonstrates the usage of the import action. This operation copies components of a namespace into another one. In the following example, we have got two versions of models. One of them have an additional reaction. Take a note that the core models remains untouched. The import action can also rename the components of a namespace. The same code can be copied many times and loaded into the same namespace. This is a powerful method to create similar paths, like cell types or something like that. More examples of Heta-based modeling platforms can be found in the Heta homepage as well as on GitHub. Thank you for your attention. Bye.